Hi, I'm RC Jim, and today I've got an unboxing video for you. This is SBD 5 Dauntless dive bomber, put out by VQ. We're going to have a look at it. Now, even before we build this, if you want to see what it turns out like, have a look at our website. On the home page of our website, we've got one of these parked on the grass there. And yes, I have owned this particular plane before. Not the one that's inside this box, obviously, but the VQ Dauntless dive bomber. I bought that second hand off of another modeler a couple of years ago, something like that. And was had some issues. My first takeoff, it pulled to the left, and I didn't control it very well, and damaged it a fair bit. I then rebuilt it again. Of course, I had converted it to electric first off, and then had that take off where I messed up and damaged it. And then after the extensive rebuild, which you can see on our YouTube channel, I can see all the details of that rebuild. I got it up there again, and it was flying beautifully, and it was coming around and had a few little glitches, and then flying beautifully again. And then all of a sudden it spiraled with a super fast roll right into the ground. Well, in the crash investigation on that, I worked out that one of the hinges on the flaps had come loose. And that flap being pulled out the way it was what it caused it to spin into the ground. So, I haven't given up on the Dauntless yet. The reason being is that my dad worked on these things in World War II and island hopped throughout the Pacific, putting these things together. And it's got a special place for me, and I just haven't found one other than the VQ that sort of seems to capture what my dad used to be involved with. So I'm going to build this one. I'm going to make sure that all the hinges are glued in properly, and I'm even going to pin those hinges to make sure they don't come out. Check everything very, very carefully as I go, and I think we'll have a much better result this time. So let's have a look at what's in the box. As we open up the box, one of the first things that you will notice is that the packaging is nothing like what you would get with FMS or E-Flight or somebody like that. This one I picked up directly from the hobby shop, and I'm glad that I did, because have a look at where that wing is. It's right on that cardboard, and your typical shipping that takes place is going to be knocking things around, and heaven forbid, what would happen to that. These didn't come with it, by the way. I had a set of Retracts that I bought many, many years ago, thinking that I would build a model with Retracts, and never got to it. And it turns out that these are just right for this model. So we're going to put the Retracts in it. Okay, it comes with the manual, and yes, I've seen that manual before. Okay, we'll get the thing opened up. And there'll also be some decals on here for customizing it. So you got the decals here, 55, USS Midway, Navy, SBD 5, number, life here. Interesting. Step. So we got the decals. We've got some just colored bits that are going to get used to put certain trim pieces on there. And then, of course, the manual. The manual, I got German and English, which is interesting. And as you go through here, you see it's pretty basic in terms of the stuff that's in there. Tells you about the glow fuel engine. Of course, we're going to put in the electric one, but you'll find that this is the only mention of the electric motor in the manual. And later on, when you get into the engine installation, is just simply looking at the nitro, wherever that is. So it's not telling you anything about an electric motor and the mounting of the electric motor or anything like that. Of course, with the other one that I had, it came with the nitro engine already installed. I took that out and built my own motor mount, and so we'll be doing something like that with this one. And by the way, it's interesting that that other one that I owned, that's the, I think it's the only model that I've ever owned that I have thrown away. Every other model, if I break it, I fix it, okay? And I'm kind of kicking myself a little bit. Why didn't I fix that one? It was bad, you know, so probably best to do it this way. And did get a good deal on this one. But nonetheless, that's got a unique place with regard to that. And I'm sure my dad went through a few of them in World War II. Unfortunately, we definitely went through many pilots. But I imagine he went through a few planes as well along the way. So it's pretty sad what happens in the time of war. So we don't certainly like the idea of warfare, but the thought of something that my dad had an integral part in, that he put his life on the line related to these things, and while he wasn't up there flying it, he was certainly on the islands that were being attacked and all of that, so he knew something about what it was, what all was happening. Okay, so it tells us about the putting the thing together. We'll go through these steps as we go on, but it gives you both instructions for the fixed gear as well as for the retracts. And someplace here they have the thing for the retracts. Fixed gear with strut. Electric retract gear installation. My retracts don't have the built-in actuator motor. They'll work with a servo, so I'm going to have to work out where to place one or more servos to work those retracts. And yeah, step by step along the way. So we'll get into that as we go. Just looking at the box, let's give you a better view of how it comes. Okay, so you got all of the pieces sitting there. And you got this tape that is sort of holding certain packets in certain places. There we got the vertical fin, and that's already got the that is loose. Oh, just totally not glued yet. Okay. So they've got it glued on one side but not the other. So we can't blame them for anything there. I'm sure in the instructions they will tell you something about putting that guy together. Okay, and there we've got the horizontal stabilizer and elevator, and again those are not glued. It can move in and out. Yeah, okay. So they've got the slots in place, and the CA hinges are there, but they're not glued in place just yet. This whole thing has just got tape sticking it together, sticking it to the box in all kinds of places. There's the fuselage. We have details for being able to put a lot of scale look into the cockpit area there. And I like the overall look of this plane. It's got weathering on the finish of it to make it look more authentic. And that's all good. The wing comes in 3 pieces, so we've got a center section down here in the bottom. You've got this, and the question is whether these guys, no, they aren't glued in either. So I can actually say it wasn't VQ that caused my crash. It was either the previous builder or maybe in the damage from that first crash that I had, something broke loose and I didn't catch it. So maybe it was my fault. Okay, so that's good to know. So all of that weathering is on the covering there. One thing they point out when you're working with this on the covering, all of the detail is on the outside of this covering. So you can't put alcohol or any sort of really tough sort of solvents onto this. It'll just smear the ink that is printed on there. So you got to be careful about that. You can use kerosene. So buy yourself a small container of kerosene if you don't have some that you'll be using to clean off excess epoxy and things like that. I found on mine that my original one, that these dive brakes were warped, and that might not be how they came from the factory, but these ones here look pretty good, and we'll investigate that further as we go. And this is the center section of the wing. So this is where I'm going to have a look to see about some servos to work those retracts. We've got a little packet here of some detail stuff. So you got this little dummy engine thing that goes on the front of the cowling, and that's actually plywood that's stamped out with the holes in it and stuff. So that is very susceptible to damage, especially when you smash it nose first into the ground. This little piece of plywood here has got all kinds of little detail things for the cockpit, and of course you got the dashboard there, so a lot of really nice detail in this plane for the cockpit and all of those things. You know, looks like they used probably a laser to cut it out, and got a little bit hot in places, but it all looks good. Okay, and then we've got pilot and gunner and all this kind of stuff in this little thing over here. So that's the pilot and the gunner. You may recall, if you watched the video about my crash, pilot came through fine, the gunner got smashed all to bits. The unfortunate thing about gunners is they're right in the back facing the enemy fighter that's coming in to do them in. And yeah, if they don't get the other guy first, then they're kind of first one to cop it. A little bit for the tail here, that's the bottom of the tail section. Covers for if you have the fixed gear, then these covers get put over the holes in the wing, or these bits. When you got the retracts, then you only have a cover on this part of the wheel, which will be in there someplace. And we've got our engine cowling, which I had a lot of fun after my first crash rebuilding this thing and patching it all up. And amazingly enough, we were able to get it looking quite nice, but not as nice as a new one. And of course, my old one had been used with a nitro plane, so it had a great big hole in the side that I had to patch up. So boy, it's really nice having a nice new cowling. These little indentations are where the machine guns line up to be able to fire through there. Obviously, we're synchronized with the propeller to keep from shooting that off. And we've even got some things for the nitro plane, fuel tank, and so forth. We've got the wheels, other bits and pieces in there, a couple of machine guns. It's a rather heavy package here. Got a lot of hardware in there and stuff like that. They say in the specifications for this that it's supposed to be a little over 3 kilos. But as I recall, with my other plane, it came in a bit heavier than that. And a lot depends on how it's built. But the 3 kilos might be optimistic. Okay, so that's all of our bits and pieces. So let's get stuck into building this guy. Well, the very first thing that we've got to do is to deal with the center section of the wing, which means that we need to sort out what we're going to do with the retracts. I just had a quick look, and I see online there's a Chinese company that's got retracts that you can buy for, 20 bucks or something like that. which is cheaper than the servo that I've got in here. But I'm inclined to think that these things are really rugged and heavy duty, and that's just a challenge to do something. So I'm going to start out at least by seeing if I can make these things work. So what I've done is I've just rigged up a bit of wire, and this is just ordinary tie wire in there, nothing special, just something to allow me to work out whether this thing is going to work. I've put a long arm onto the servo, and it's looking like I don't actually need that long of an arm. Got a little bit of wood underneath there to get that off, and the thought here is that this tire can go all the way down to there and still clear that servo. Okay, and it doesn't have to go that far. And the other thing is that I will be angling these landing gear forward. Typically what happens when you are landing one of these tail draggers is they like to nose over. So what I want to do is have these things not straight up but angled a little bit forward so that it's less likely to nose over. So angling it forward also gives me a little bit more room there in the back. So that would seem to indicate that we could fit a servo in there. So now the tricky bit is with this servo just sort of sitting there, and with our servo tester here, I want to move the servo. I want to hold on to that, and pull this thing such it goes up, and that needs to be all the way at its thing, and that's not yet all the way on our travel. Yeah, pretty well all the way on the travel. Okay, so that's locked in there like that, although that servo's farther forward now. So I don't think we quite need all of that travel. When the landing gear is down, this thing is up, but that's fine because the wheel is out of the way. Let's say that it's there. And that's all the way in the locked position. Okay. So now we bring it down. And it's kind of hard to hold everything, but it would seem to be the case that that's going to be okay, and that's going to clear, and it's got a locked position down below. Well, we're getting the retracts sorted out here, and that's where we've gotten to thus far. So what do we want to tell you about this? First off, as I looked at the height of what the retractor is going to be and still have the wheel fit into the wheel well, I realized that I had a little bit of an issue. This I haven't actually checked yet. Yeah. Okay. So we've gotten, you used our extra little bit there. So the issue that we had is that if I didn't have these spacers in down here, that as I looked at the height of that compared to, this is the retract, or not the retract, it's the fixed gear from the old plane. If I had that down in there, this one was lower. So what I've done is I've done a variety of things to get it roughly the same height so they can put the same size prop on it. So I've added in spacers down here. Those will get epoxied in place. There's one thin one here and a fat one and a thin one there. Then I'm going to extend this opening a tiny bit. So as you see or saw, and we'll see again with this when the thing is down, we're extending it just as far as we can, and so it's going to go about 3 mil or so into that side there. But that's okay because there's a trim piece that goes around there that I can scoot that way and cover up whatever it's missing and just move that out a bit. And there's nothing underneath there for, you know, a good 12, 13 millimeters, half inch, something like that. Okay, so that was that. So anyway, before I bent this, what I did is I put a mark on it where I felt it needed to be, and that was this top mark here. And then I had a look at the bend in this one, and I estimated that it was about 1.5 diameters from the center line of the axle going through the wheel down to where it was straight. So I figured if I put this in the vise at the top of this fat piece of tape here, that was 1.5 diameters below that center line that we're looking for. And it just turned out, and I measured that was 13 millimeters from the center there. And if I just check right now from the center of the pivot, 13 millimeters right there, it's pretty well spot on to where that axle is. Okay, so that was a pretty accurate way to do it. In doing the bend, I don't have a proper bending tool, so what I did is I put it in the vise. I used all that masking tape on there to try and keep it from scarfing up the landing gear too much. I put this piece of wire in the vise with a clamp on it out here to hold it there, and then I took a piece of steel rod, heavy steel rod, and I got it on out here and it had tape around it as well, and pushed basically as hard as I could, and I got it down to maybe about 45 degrees, and then I started whacking on it with a steel mallet, instead of what we call a mash hammer here, getting it down straight. Then, having gotten it down straight, and of course I was very careful when I lined this up. I lined it up with a bench to make sure that that was square, and I was pushing straight away. I then utilized a square to make sure that I had it square here, and did a little bit extra tapping to get it down to where it was pretty square. Then let's see, it was angled forward a little bit. So what did I do with that? With that one, I just lightly clamped it on the vise this way, and just with my hand pulled it back a bit and got it pretty straight. It's still going a little bit forward, but with a few landings that will be back. I find it amazing on landing gear how hard it is to bend them by hand, and yet how easy it is in a landing to bend the thing. Yeah, that is totally crazy. Okay, so hopefully I'll be able to replicate that when I do the other one. With this plywood, I'm making it a little bit proud. That is to say that it sticks out a little bit farther than the edge below it, largely because there's these screws, and it allows the plywood to come a little bit farther, and I figure the more meat in the sandwich, the better, So, get that out there as far as I can, and basically is enough to where this can fit in there. I've also extended it out underneath the structure there, because it's got a gap underneath, and then on this one, on this side here, I've ground it out to give clearance for the spring thingy here. So that is looking pretty good. So this slides underneath there. That'll get epoxied in place. I've sanded it a bit where they've painted it. They've spray painted the inside green. So I've sanded off as much as that as I could there. And we'll use epoxy to get that in place. And do the same on this side over here. Get screws to go down. I didn't want to put the screw holes in until I sorted all this out, just in case I had to shift something around. But it looks like we're going to be okay there. So, all good. We've now got our retracts bent, wheel in place, collars on both sides. We got our little packers in there to bring it out a bit. We do note that this is just bent in a little bit, and with that, when we go to put it in here, we see the tire is hitting against the bottom. I was concerned that maybe it was the thing sticking out the end, but no, the way it's going in, it's the tire. Partially that's due to being farther forward, in that it gets shallower up towards that end, and partially because this has been in. We kind of like the idea of it being forward a bit, but we can come back a little bit, and then certainly we can come up a little bit. With regard to opening this up to allow it to come out, we noted before that we had space in there, and we saw where we could bring it. But in actual fact, what we will do is we will do the bending on this to get it to where it's going to be. But then with that in the place that we want, we will do our best to center the wheel into this thing here in such a way that we don't have anything showing of the opening around the ends. This won't come back all the way anyway. You know, it's probably not much good there, so it'll probably get cut off just short of that and just short of this. Just trimmed up, you know, the way it's going to look the best, but we won't worry about that last little bit there, not on this side anyway, and we certainly won't have the thing coming across the bottom there. So we will reposition this. We will make a new mark for where we're going to cut it. We note that it's overlapping a little bit over the leading edge, but even with it in the proper position, it overlaps a little bit. So for whatever overlaps, we will just trim it straight, and if it needs a little bit of filler in there, we will. But we got this flat bit up here that's going to be mounting up against the fuselage, and we certainly need to clear that. So it's going to have to get trimmed off if it's sticking out up here. But all of that's not a problem, and it gives us the longer landing gear that we want, and it gives us that forward sort of position that we're after. So that's going to work out well. And similar with this one over here, you know, be the same sort of thing. Let's put on our engineering hats here. Now, for most of you guys, you don't have an old Retract sitting around, and even if you did, you'd rather pay the, well, I don't know, whether it's going to be $100 or whether it's going to be $30, depending on whether you buy a decent one or, you know, the old cheapo. But nonetheless, most likely you're going to buy the modern variety that has a little actuator built right on here. And that's obviously the best way to go. But I've got these, and I cannot resist the challenge of making it work. Okay, that's part of the hobby for me, is looking at these challenges and thinking, what can I do, you know? So anyway, we've got this thing set up now to where the Retract fits in there, fits in the middle. We've got our trim bit to where it can fit right around the outside, and the wheel's pretty well in the middle. We've bent the rod such that the Retract can go in easily to get it in the locked position. So that's all fine, and when it's up in the locked position. Got a little bit of angle on it. You know, we might think about bending it the other way, but we have to be careful that we make sure that we got room for it to go in there. And really, you know, if it's angled out a little bit, that gives us a little bit extra track, and I don't know. But anyway, I'm not going to worry about that just yet. That's a question of bending wire and how to bend it. I guess ideally what we'd be doing is we would bend it out a little bit farther and then straighten it up to get that perpendicular to the ground. So that would be the thing to do, to bend it out, then straight, and have that be nice and straight on the ground. So anyway, that could be done, but we won't worry about that just now. Let's have a look now at what sort of pull these servos can give us. HS225BB specs, you probably can't read that, but 3.9 to 4.8 kilos per centimeter. Okay, so we are, let's see, can actually multiply it a little bit down there. So when we're straight up, it's 1.6, let's call it 1.7 centimeters. Oh, it's not kilograms divided by centimeters, it's kilogram centimeters. I wish these guys would use proper terms. They say kilogram per centimeter, but torque is actually force times distance, not force divided by distance. So it throws our equation right off. So anyway, for all of you students of engineering out there, 3.9 kilogram centimeters, so kilograms times centimeters, and we divide that by 1.7 centimeters. So they cross out the centimeters, they eliminate each other. So you got 3.9 divided by 1.7, so roughly 2.3 kilos. 2.3 kilos, and what we need is 0.9 of a kilo. So that's saying that this servo has got enough oomph to pull that thing up, at least in ideal conditions, and given that we've got more than double the capacity. Let's see, that's already pulled out. Okay, so just repeating that again. Get it up there in the locked position. So to bring it down, well, we got it zeroed out first. Okay, we pull on it, and I saw 0.2. I probably pulled on it harder than I had to, but obviously really easy to pull it down. What about getting it back up again? Okay, so we got it in that position there. We got it zeroed out, and I better get my hand out of the way so that it can come up. Okay, so we've got it 0, and we pull on it. And I saw 0.9 something was the highest. And obviously how hard you pull on it is going to make a difference too. How quick you pull on it. Hang on, let's get that out again. Okay. I still didn't get it to go up over 1. Pulled on it as hard as I could. Pulling it very slowly. Slowly. 0.88. So that one was 0.88 in the maximum. And keep in mind, we're not pulling exactly straight on the thing, you know. Of course, out here it's better, but still that's got a bit of an angle on it, so we're having to pull a little bit harder. So the next thing has to do with servo placement. And originally, I was thinking to get as much distance between the actuator arm, this little guy here, and the actual servo to where any angle on it is less of an impact. But in getting the servo up into this position up here and getting the wheel down to where it's not going to interfere with it is a bit of a challenge. So what I've decided on doing is to mount it up in here. Yeah, so that position up in there is kind of where I was thinking of. But then the thought was, well, we want to be precise in how we locate that thing. And so anyway, I've just plotted out a few things onto a piece of paper here. And so this is the top of the retract. So that surface up there is the top of the retract. That's the shaft center, so the steel shaft there. That's the center of that shaft. And then the mark is the looking at where this attachment point would be. Okay, and I've measured out that it can come out 27. Yeah, travel is 27. So that's the total travel, including the lock position. And we've got a little bit of leeway in the lock position. It stays locked for a fair bit. So we can have it come out just slightly short of that and still be good. And the same sort of thing from the locked up position. It can come out a fair ways before the lock is released. Okay, so we can have it a millimeter or so short of that just to make sure we don't want the servo to be constantly pushing against something. We want it to come to a point where it's got freedom, so it's not drawing a current. Well, I might mention too, in trying to get enough clearance for this thing to fit down in there, the tire was hitting on this rib that is in there, and I didn't want to carve down on that rib because that's structure. And I had one of these, we had a little collar like that in here, which was pushing the wheel farther that way. So what I decided to do, and then I found without anything there, the wheel was binding up on the radius of the wire where it was bent. So what I decided to do is take a washer and just glue it on there with the glue on just this one side of the washer, and that can act as a stop to keep it as close as we can that way. And this thing clears, believe it or not. So that clears and that's hitting. But this is farther back away. It's coming up as it comes towards us. This is hitting the rib, and that has clearance to that there. So we could shorten that up as well, but for the moment it's not an issue, so we're leaving it as it is. So now, as you think about our little plot here, okay, we got the shaft that goes in and out like such, and then I basically got the servo out and I set it on top of my paper, and I said, okay, what's going to be the ideal thing? Now you could plot this all out if you wanted to, but I just got thinking, okay, I would like it to be at the two ends to be reasonably far over to kind of help lock it in and have that extra bit of push there. You know, when it's on an angle like that, any sort of force on the servo is going to be multiplied as far as what happens on the thing on the outside. And it comes up to super high when it's actually absolutely straight. But by the same token, you don't want to have everything, like if well, I do have that lined up pretty well on the thing. Both of these, you can see that's the one point and that's the other point. So that's the point with the servo in this position, and when it's 100% the other way, it comes around to that point there. So both of those points are very close to the axis of this line, and so that's going to be very efficient. And then we just need clearance going across there, and given that the gear is up when this thing is in that position there, as it comes down, this is moving out of the way and down totally out of the way. When it gets to the bottom, that's all good. So then I had to think, okay, what's the best way to mount this? At one time I was thinking just double stick tape to the bottom, but first off, that wouldn't get it as high as what we want. And I worked out, in order to get the 27 millimeters of travel, I can actually have it on this closest hole here and still get that 27 millimeters from one end to the other. So anyway, we're well above the bottom, so double stick tape probably isn't a great idea. And furthermore, as you think about the double stick tape, I was questioning security and all of that. So what I figured I'd do is make a little attaching thing for it. And so I've come up with that right there to get us up the distance that we want off of the floor. And now as I'm thinking about it, okay, originally the thought was just run a couple screws from the other side. I'm not exactly sure what this material is. It doesn't feel like it's just simple balsa, but it's certainly not anything terribly heavy. So I'm thinking it needs some reinforcement. So the plan is I'll put that down first. And I've got this to where it fits exactly in the corner. So when you put this thing in here, so you push it right into that corner, that's exactly where we want it. So it's got support along that side, and it's got support along the back as far as any twisting of the servo might be concerned. So this tray here is fitting right into the corner. Servo is screwed to that. These things are epoxied down. So it's got that covered. So then my additional thought is, okay, let's epoxy this thing onto the bottom. And what I'm going to start out with, I think, is just some of the thin double stick tape to stick on there that doesn't add any thickness, doesn't have any foam in it, but just mainly to make sure that everything is okay before I start screwing screws into the thing. And what I'm going to do is take this little bit of balsa and have it glued on the side. So that will be glued onto that. This will be glued into the bottom. And then the servo will be double stick taped into that spot. And so with that, we've got 3 sides that are constrained with something that's epoxied right in place. And then with this tray just being double stick taped in there with a thin double stick tape, that doesn't have to do much other than to keep it from falling out. So for a short term, that will be okay. And then at some stage, in addition to the double stick tape, I'll run a couple screws in. And when I go to run the screws in, I'm going to aim for these vertical bits here to try and get some good meat in there to have something decent to screw into. I might mention as well that when I first put this into the corner there, as I looked at it, there was a bit of a gap on the front, which is indicating that the support going this way wasn't quite square. It was actually angled a little bit in that way, angling in, leaving a little bit of a gap out here. So what I've done is I've put this in the saw, and I've just given it a very tiny bit of an angle going in there to get it to where it's going to fit solid and it can't twist one way or the other. Well, we've got a little panel made that fits into the corner there. That's going to go hard into the corner. And I just put my put a little bit of pressure on it just to make sure it's hard into the corner. I want to make sure that when I glue it in that I'm still going to be able to get this in. Pop this in there. And I note that as you see this panel over here, I've had to cut this post down to fit under there, but that further locks it in, so that when I get her in there, worst comes to worst, we might need to sand this down just a little bit. I'm doing my best to keep it hard into the corners so that we can simulate what it's going to be like when we actually have the servo on it. At the moment, we can get it in there. Okay, so I can get that right into the corner. It's sitting right in there like a hand in a glove, better than that. It's locked in underneath that piece there, locked in on 3 sides on the bottom. That's going to be mighty secure. So I'm not going to be at all feeling bad about just a couple of screws holding that in there. And again, like I say, I'll put that tape on it to start with, I think. And just in case I decide to move it, I don't want to have to move screw holes. So I'll start out with a tape. Okay, all the way to the back. Yeah, that is looking extremely secure. Okay, this will go in here like this. Okay, when the gear is down, that's pushed in, so the arm is that way. When the gear comes up, the arm will be out this way, coming in as the gear comes down. So clearing by 6 millimeters in there, but it clears. So that's going to do it. Here's a glimpse at what we're doing with regard to epoxying that plate in there. This is the one that, not that the servo attaches to, that's the one that the servo attaches to, but the plywood that goes underneath that's in the corner. I've got that in there with epoxy underneath it. I've got greaseless paper over top of baking paper over top of it. I then put 2 little blocks on top of it and this piece of plywood that gets me to where this foam has got some light pressure applied. So put those things in place, slid the foam in there, that's got mild pressure on there. So that's keeping pressure on that plywood with the epoxy on it to give a good bond to the material below it. This stuff, it's been spray painted on the inside, and I'm thinking that the roughness of it is going to make up for the fact that it's got paint on it. You know, up here where we were working on it, I did sand it off, but trying to do that in there, I wasn't so sure about that. So anyway, I've just simply left it as it is with the epoxy on it. Yes, I recognize we're still just on the first page of the instructions. And we're not hardly doing anything that they tell us to do there. Actually, I guess we're not on the first page. We've progressed up to that page, whatever that is, not the third page. But anyway, we're not doing what they say anyway. So anyway, the next thing, we've got our servo in there. The epoxy is hardened on the plywood below. I've pushed the servo in, really nice tight fit, so that's really snug. And so now what I need to do is work out what to do with the linkage, because it's going to be a little bit difficult to work too much with that linkage. You know, when it's down, it's all covered up. But anyway, what I've done is I've taken the calipers and I've had to get some light in there to be able to see the holes and so forth. But I've taken the calipers and I've measured the distance with it all of the way in. Now I recognize it can be a tiny bit less than this and still be okay, because we don't want it hitting hard against the stop anyway. So 39.6 millimeters is what I've measured, and so now I need to set up a linkage that's 39.6 long with the ability to adjust it as necessary. Okay, what we've done here is we've measured our 39.6 millimeters. Obviously 39 and a bit millimeters can be adjusted here by screwing this in and out. And we can also adjust this in and out down there. We've got it on a little platform, and we've got that. I originally was going to put the ball link up here on the retract, but it didn't quite have enough clearance for that boss, that round part on the end there. So I reversed it to put the ball link on the servo. I'd prefer it the other way, but you do what you have to do. So anyway, we slide this in here. And we get our servo in its little spot in the tray. Okay, that's now down into the tray. Okay, as I look at it right offhand, let's twist that just a tiny bit. Trying to twist the end of this, which it does do. Okay, that's a bit better. Okay, make sure that's all the way down in there. That's not stuck in yet. It's just simply sitting there. Okay, so we have first off just a general look at how things are, and we see that the little linkage here is pretty close to this piece of wood here on the side. So we're going to keep a close eye on that. We might end up taking a Dremel and giving that a little bit more clearance. We see we got clearance. It's all of the way that way, and we've got clearance between the white thing here and the black arm. So that looks good. So now, with that in mind, we will carefully hold the retract in place. We'll just let that sit there, and we will work our servo. And yes, it goes down, and it's not complete. Well, yeah, you can see that the servo is pushing a little bit beyond where it was when it's all the way in there, so it can probably go with a little bit less travel. It certainly brings it up fine. And then same thing, it's trying to pull a little bit too hard on the far end, so I need to reduce the travel on that. And maybe give a little bit of clearance there, but essentially I'd say that's a success. Okay. this is something that can be programmed to go slow and come back down slow. And with the servo fastened in place, it'll be, you know, a little bit more predictable or, you know, steady. So I think we got that one solved. Well, thank you for watching this video on the build of the VQ Dauntless dive bomber. I'm excited about this, and hey, I'm enjoying it as we go, because it's allowing me to put those engineering skills into work again. It's been a while since I've had to do it professionally, but nonetheless, yeah, the desire is still there to work through problems and solve them and figure out good ways to do things and think about the principles involved of physics and all of that. And yeah, some of you enjoy that. Some of you just want to take the plane and fly it. So for you guys, go out and buy an ARF. Well, I guess this isn't our ARF, isn't it? I'm just making it into more like a complete build. But anyway, nonetheless, do it the way you enjoy it. But I think in watching these videos, you'll probably learn a few things, and you might even have some suggestions for me to make it something that is even better yet. So put your suggestions in the comments below. Make sure you subscribe so that you got all of these things handy, and then have a look at the next video that's coming up. You have a great day and enjoy your flying.